Good morning, everybody. It's a cold, rainy day out there today. I think autumn's here. Wintertime will be right behind it. What we've got here is a dual charge master made by Simco, Industrial Static Controls. This circuitry right here, this makes the positive high voltage at a max of 30,000 volts. Yeah, be careful when you're working with this stuff. Make sure you're unplugged from the wall when you get inside there. There's another circuit, and I'll show you that in a little bit. We're going to test this bottom one before we cover it up with that other circuit. But the other circuit that sits up here above this one makes the negative 30,000 volts. Shoo-wee! So between the two of them, you got 60,000 volts. You got to be real careful around this stuff. When we do our measurements, I use a high voltage probe. You can't measure these high voltages with a standard probe. You have to use a high voltage probe. And I don't look at these voltages with an oscilloscope. I don't have a probe high enough to protect that oscilloscope from that high voltage. So I never put an oscilloscope on this stuff either. I'll show you that high voltage probe here in just a little bit. What we've got down here is this high voltage module, and this is the positive side. I constructed this to replace the bad high voltage module, and if you want, I've got quite a few videos on how to put this together. They're long. It takes me half a day to put this together, and then there's another 24 hours to seal it with this potting compound. I don't know if you can see it in the video, but there's a clear two-part compound that seals this and insulates the leads, the exposed leads of the diodes and capacitors and resistors. So that takes a while. How does this work? Well, there's a switch mode power supply IC underneath this metal bar right here. It's a UC2524. That drives into a small transformer. You can't see it underneath here either, but it's under here, and that's the firing transformer that turns these power MOSFETs on and off. The two MOSFETs drive into the primary. They're not in parallel. One drives into this lead of the primary winding of this transformer. The other one drives into this other lead of the primary winding of that transformer right there. The secondary of that transformer drives into the high voltage module. The output of the high voltage module is right here on this plastic block, that plastic insulator. Now you'll notice there's a red and white wire exiting that high voltage module right there. That's the voltage feedback that's fed back into the switch mode power supply IC to control the voltage. Let's pop right up here. That's how you adjust from 0 to 30,000 volts. There's a meter right here that tells us what the voltage is set at. There's an LED right here for the positive and negative side. There's two LEDs. They're the check system LEDs. When you've got the potentiometer turned all the way down, this LED will be on. Once the voltage starts to come up, whatever you set it at, above 0, that LED will go off. Now that LED also comes on if there's a problem, a short circuit, or if the high voltage has a problem, this LED will turn on and it will throttle that high voltage back to zero. It'll shut itself down. I'm going to move the camera so you can watch us measure the output. Give me a little bit. We'll be back. Here's a close-up of the capacitor diode network in the high voltage module. Here we're at the back side of the charge master. There's an enable input right here that you have to jump out. I jump it out with this wire right here. You have to jump this out, otherwise the charge master will not provide the high voltage output. Now, down underneath here is the line plug. Here in America, it's 120 volts AC single phase. We've got a metal rod right here that I'm going to use as a contact point for the high voltage probe. Now when this is plugged into the output over here, do not touch this. Do not touch this. This will hurt you when this charge master is turned on. Now, I'm not plugged in, so I'm not worried about getting shocked right here. Grab this wooden block right here, and I'm going to push that against the output connector of the charge master so we have good electrical contact. Now let's plug it into the wall. Once we're plugged into the wall, we do not touch anything inside this charge master. Even when the 120 volts AC is turned off, we don't risk it. Grab my meter, see if I can put it someplace where y'all can see it. Y'all see that right there? Turn that to volts. Now here's the high voltage probe. Right here. It has probes for your meter, and it has a clip for frame ground. All that comes out of the back of the high voltage probe. So we clip the high voltage probe to frame ground. Let's turn this on so we can see. This probe is rated for 40 kilovolts DC and 28 kilovolts RMS, root mean square. Here's the point, the contact point, that fork that we're going to touch to that metal bar down there. At no time, I can't say this enough, at no time don't touch anything inside the charge master or at its output, that rod right there. It will light you up. We want to live to see another video from Peepaw. Okay, here we go. Turn it on. Okay, I'm increasing the potentiometer, and the meter says we're at 10 kilovolts, and we have 10.03 volts on the meter, indicating that we have 10,000 volts at that probe tip right there. Let's increase it. I have 15,000 volts on the meter of the charge master, and I've got 15.62 on the flute meter there. There's 20,000 volts on the meter of the Charge Master and 20.71 volts on the Fluke voltmeter. Oh yeah, we're starting to arc over. Did you hear that? We're ionizing the air now. Okay. Oh, I smell it too. I smell it. There's 25, 26 volts on the Charge Master meter, and we have 26.4 volts DC on the Fluke voltmeter. Let's try to go a little bit higher. Oh, you hear that? We're arcing over. We don't have good contact between that rod and the output of the Charge Master. I'm going to turn it down. Did you see the sparks right there? Oh, imagine that. Okay. We took it up to 26,000 volts. 4,000 volts more, we would have made it to 30. But I'm going to call that good. I'm going to get you closer to that meter right there. We'll get a better look at it. There's 10,000 volts on the Charge Master's meter. There's 15,000 volts on the Charge Master's meter. 20,000 volts on the Charge Master's meter. And I think that's as high as I'm going to go this time. Okay, let's back it down to 0. There we are at 0. Okay. Let's come around to the front of the Charge Master. I'm going to turn it off. Let's come around to the front of the Charge Master. And I'm going to turn it on. Here's the positive check system LED. Notice that it's on right now. Our meter on the positive side is at 0, and we're going to increase that voltage output to 10 kilovolts. There we're at 10 kilovolts on the meter. Notice our LED went out. If we had a problem, that LED would turn back on and the meter would drop to 0. Self-protection. There's 15,000 on the meter. There's 20,000 volts on the meter. It's 25. And there's 30,000 volts on the meter, indicating we have 30,000 volts at that output. Let's turn it back down. Okay, we're at 0 again, and our positive check system LED turned on. Now I'm going to install the negative side. We'll test that. Here's the negative circuitry, minus the high voltage module. Get a good look at this right here. Here's the UC2524AN. That's the switch mode power supply IC. Now, it drives into a driver IC that's underneath this metal plate. And that driver IC fires into this switching transformer, the primary of the switching transformer. The two secondaries fire into the gate of the power MOSFETs, which switch this transformer right here. Let's put all this in the cabinet. This is a little bit tricky because here's our enable terminals and here's our meters, and they always get in the way, so you have to pry the walls apart a little bit when you're going in. There we go. Just clear the meters right there. Okay, let's make sure we're not crushing any wires on the positive side. There we go. We okay on that side? Okay, we're all clear on that side. Now we're going to install the plate mounting screws. There's 2 on this side, there's 2 on the back, and there's 2 on the other side that hold this plate to the housing. Bit loose because nothing lines up. When I get everybody started, I'll tighten them all down. There's the 2 in the back. Now the last 2 this side. Especially these 2 right here that don't line up, you have to tug on the metal plate to get them screw holes lined up. Come on now. There, it started. Okay, now let's tighten everybody down. These 2 holes right here are the mounting holes for the screws that hold the plastic output block to that plate. And this I don't understand this, but this protrudes out the back end, and so I always have to make sure it's removed, otherwise I can't get this whole assembly mounted inside the housing. So it makes it a little bit difficult. I've got to go up underneath, and there's not a whole lot of room because the positive side, its mounting block is in the way underneath here. Here's the negative side. So I'm going to turn the camera off so y'all don't have to hear me cuss while I'm installing this negative side's plastic output block. All right, I'll be back in a little bit, folks. Hold tight. There we go. We almost got it. I get them started by hand, and then I use this go around the corner Phillips screwdriver to finish tightening everybody up. Let's tighten that one up. That's good. And the last one. And that one's tightened up. Okay, there we go. Hook up our enable. This is green and white wire right here. They connect to the terminal boards on the back. Hook up our meter, they go right here. you've done a few of these, you don't have to figure out what goes where, you just automatically know how it all gets hooked back up. Hook up our front panel potentiometer for the negative side. That comes through here. Let's bring this down through the meters. Come on up here. It comes out through there. That down. Hold the back side of it while I tighten it up. Hook up that indicating LED last. Install the cooling fan. Far away glasses. There we go. There we go. There you are. Cooling fan wires connect over here. They're the fuses. Okay. Now we're going to plug the line voltage input to the negative circuitry to the line voltage switch. Plugs in right there, just like that. Brown to brown, and blue to blue. Don't get them backwards. Okay. Finish installing this knob. Almost there. Here's a negative high voltage module. I made this many years ago, and this unit had been running and running and running until the positive side failed. So let's see if we can put that negative side on. Get everything situated here so I don't crush no wires. Put that right there. That all looks good. Oh, I dropped it. Get my hands down in there. Come on out of there. Don't fall down again. Hook the transformer up to the high voltage module. Hook the feed back up. That's everything. We're ready. Now before we test the high voltage with the high voltage probe, let's make sure it powers up okay. Line voltage. And let's leave that right there for now. So I have to hook up the enable on the negative side. Jump those two terminals together. And that will enable the high voltage output. There we go. Plug that into the wall. Here we go. Be careful. Okay, we got a negative LED and a positive LED. Both meters are at 0. I'm going to bring that negative voltage on. Negative LED went out. We're at 10,000 volts on the meter. There's 15,000 volts on the meter. $20,000 volts on the meter. There's 26,000 volts on the meter. We're almost there. And there's 30,000 volts on the meter. We'll put that metal rod on the output. After I turn it off, we'll put that metal rod on the output and we'll measure that output on the negative side with the high voltage probe and my fluke meter. So let me turn this voltage down. We're at 0 volts on the meter. The negative LED come on. Let's turn that off. Unplug ourselves from the wall. Make sure that you are unplugged from the wall when you put that metal rod in there. You absolutely do not. I can't stress this enough. Absolutely do not work on this high voltage area with it plugged into the wall and turned on. You'll light yourself up. Okay. Here we go. Let me move the camera so y'all can look at the meter when we make those measurements. Okay, we are turned off and unplugged from the wall. I'm going to insert the metal rod into the negative high voltage output. I sure would like to insulate that. Put a piece of cardboard between that brick and that metal rod. I don't know if there's any material in that brick that would conduct. Let's see. I can do this. Let me do this. Set this down here. There. I know that wooden block right there won't conduct. We'll do that. There we go. Set this meter over here where y'all can see it. Okay. Now let's frame ground our high voltage probe with the clip. Set our meter in volt mode. Can you all see that? There, that looks good. Okay. Put the fork of the high voltage probe on the metal rod. And we'll make that measurement. Let's plug ourselves in first and turn it on. Okay, we're turned on. There we go. That's good contact right there. There's 10,000 volts on the meter. We're a little bit low, but I'll show you how to make that adjustment to bring it up. We have negative 9.77 volts DC on the meter, indicating that we have 9,770 volts at the output, right there at that metal rod. There's 15,000 volts on the meter and negative 14.38 volts on the fluke meter. That's 15,000 volts on the charge master meter. There's 20,000 volts on the charge master meter and negative 18.49 on the fluke voltmeter. Okay, I'm going to turn this down. I'll show you where we make that adjustment. Let me move the camera over here around the corner. There's a potentiometer right here. It's called voltage trim. It's potentiometer R66. That adjusts the output at this plastic block here. Let me get a screwdriver and we'll make that adjustment. I'm going to come in from the top down here. First, let me set the meter. Okay, there's 10,000 volts. That would be negative 10,000 volts on the charge master's meter. I'm going to come in from the top down here. And I'm going to go in here with the screwdriver and make this adjustment. So that it says 10,000 volts. There we go. Negative 10 volts. Oh, let me get it up a little bit. There we go. It said negative 10 volts, negative 10.06 volts on the fluke voltmeter. Okay. Now, let's do some more checks here. I don't want to go too high because we start ionizing the air and you can hear the output crackle. There we go. That's 15,000. Eyeball negative 15,000 volts on the charge master's meter, and we have negative 15.37. Let's go up to 20. That's pretty good. There we go. There's 20,000 volts on the charge master's meter, and we got negative 20.02 on the fluke voltmeter. That's good. That's good right there. You turn that down. I'll turn it off. And we're done. Now all we got to do is install the lid. Plug that from the wall. Got to move that high voltage probe over here so I don't get it all tangled up with the line cord. Plug that right there. That's that. Did you all enjoy that? These are a lot of fun to work on. Just have to be careful. You have to be careful, especially with these high voltage modules. And when you're making your measurements on that metal rod right there with the high voltage probe, just absolutely do not touch that metal rod. Oh, folks, I've been shocked before, but never by nothing that high. I don't want to find out what it feels like. I'd like to live to another day if I could. All right, folks. Thank you very much for stopping by and watching me put this thing back together and test it. I hope you all's having a good day. Enjoy the time with your family. Enjoy the time on this earth. We live live a long time. But when you get to be my age, those years go by quick. Shoot fire. Yesterday was January 1st, and here we are at the end of the year already. That's how fast time goes when you get old. Your perception of time changes. I wonder why that is. I have to study up on that one day when I get the chance. All right. We'll see you next time.